Interesting story. New audio tapes from the Apollo 10 mission reveal an eerie experience on the dark side of the moon.
Sound in the normal sense needs a medium like air, water, or rock to travel as pressure waves. On the moon, the air is basically a ghost. Its exosphere is so thin that molecules are so far apart, they might as well be in a long-distance relationship. If you stood on the lunar surface, took your helmet off after a bold and very short-lived decision, and screamed, no one a few meters away would hear you because there is no dense atmosphere to carry the sound waves between you. Inside your suit, however, sound behaves normally through the air and solid parts of the suit, which is why Apollo astronauts could hear each other through radio mics and also hear their own tools banging around. So when people say sounds on the moon, they're really talking about vibrations in solid rock, radio signals, or data turned into audio, not air shaking like it does on Earth. So if the moon is basically a cosmic mime, what exactly are all those creepy recordings labeled moon sounds you've heard online pretending to be? During Apollo 10, as the spacecraft looped around the far side of the moon and lost contact with Earth, the astronauts heard what they described as outer space type music and strange whistling noises through their headsets. The audio was later declassified and made famous in shows and clips that leaned hard into the aliens tapping into NASA's Spotify angle. But the explanation is gloriously unromantic. It was radio interference between the radios in the lunar module and the command module, both operating close together and creating odd woo-woo tones when signals mixed. Apollo 11's Michael Collins also heard similar eerie woo-woo sounds when both spacecraft radios were active, and noted that once the modules separated and conditions changed, the ghostly chorus promptly stopped. So no, the moon wasn't broadcasting lo-fi alien beats to study and relax to, it was just physics doing a bad impression of a theremin. If the far side wasn't actually singing, then what is the moon really saying when we listen more carefully? The Apollo missions left seismometers on the moon, and those little instruments eavesdropped on the lunar interior for years. They recorded thousands of moonquakes and meteoroid impacts between 1969 and 1977, revealing that the moon is not a frozen, perfectly still rock. It shudders, rings, and occasionally absolutely rattles its own teeth. Moonquakes come in several flavors, deep ones originating 800 to 1,000 kilometers down, shallow quakes that can reach around magnitude 5.5, thermal quakes caused by the surface expanding and contracting with brutal temperature swings and constant impacts from meteoroids peppering the surface. Some of these shallow quakes are strong enough that future lunar bases will actually have to be engineered not to snap like cheap IKEA shelves. When scientists convert these seismic waves into sound, the moon essentially rings with long, echoing tones because its interior is dry, rigid, and not as good at dampening vibrations as Earth. So if the moon can rumble like a slow-motion gong, what happens when the universe decides to throw actual bullets at it at tens of kilometers per second? Unlike Earth, the moon has no thick atmosphere to burn up incoming space rocks. So meteoroids don't politely disintegrate, they slam into the surface like cosmic sledgehammers. The Apollo seismometers recorded more than 1,700 individual meteoroid impacts in less than a decade, each one sending sharp seismic waves snapping through the crust. When these impacts are translated into audio, they often sound like sudden cracks, pops, or sharp taps, followed by long, fading reverberations as the moon's crust wrings out the energy. In a way, the lunar surface is constantly being played by the solar system, like a drum that never gets a break, and every meteoroid is another uninvited drummer in the worst jam session of all time. But if the moon is always being hit and always shaking, why is it that heat and sunlight alone can make it creak like an old haunted ship? Lunar day and night are brutal. The surface can swing from oven hot to deep freeze, causing the upper layers of rock to expand and contract dramatically. This constant thermal stress leads to small fractures, slips, and microquakes as the crust flexes, relaxes, and generally fails to cope with its work-life balance. These thermally induced quakes can build up in patterns, and some recent reanalysis of Apollo-era data uncovered tens of thousands of small seismic events, many clustered near features like the Apollo landing sites. Turned into sound, these are more like subtle ticks and pops. Less Hollywood explosion, more old house settling, if the house was made of basalt and being roasted by an unshielded star. If temperature alone can make the moon twitch, what happens when gravity itself starts yanking on it like a cosmic stress ball? Earth's gravity doesn't just hold the moon in orbit, it flexes the moon's interior as well, creating tidal stresses that trigger some classes of moonquakes. These tidally triggered quakes tend to occur at roughly monthly intervals, lining up suspiciously well with the moon's orbit, like a reminder that even in space, you never really escape family pressure. When researchers analyze and sonify these signals, the patterns reveal a kind of slow, rhythmic pulsing, less jump scare, more background ominous hum from the basement you pretend not to hear. This constant gravitational kneading helps scientists infer the moon's internal structure, a thick crust, mantle, and a small core, reconstructed from how these waves move and echo inside it. But if all of that is happening through rock, how did we end up with recordings that sound like actual audio from the dark side of the moon? Most of the sounds people associate with space, and by extension with the moon, are not actual sound waves recorded in air, but sonifications, data converted into audio. Scientists take measurements like electromagnetic waves, plasma oscillations, magnetic field variations, or low-frequency waves, and map them into the human hearing range by speeding them up or shifting their frequencies. NASA and other teams have used this technique to transform various kinds of space data into audio, revealing haunting whistles, whooshes, and hums that make the universe sound like a horror soundtrack composed by physics itself. While this is more common for things like plasma waves around planets and the solar wind, the same concept can be applied to lunar data. Seismic vibrations, electromagnetic signals, and even radio interference can all be translated into those eerie moon sounds that end up in documentaries and sound libraries. If we can turn invisible data into creepy audio art, what does that say about the moon as an actual place to stand, work, and listen? When Apollo astronauts walked on the lunar surface, they were technically inside their own portable sound bubble. Their suits contained air, rigid components, and radio communications, so sound traveled from their tools, footsteps, and even their breathing through the suit and into their microphones. The iconic one small step moments include the sound of their boots scuffing regolith and equipment clanking, but those sounds never touched the lunar air. They went straight from suit interior to radio to Earth. Inside the lander and command module, astronauts also heard environmental noises from pumps, fans, switches, and guidance computers, creating a mechanical background soundtrack that was anything but silent. If someone ever builds a permanent base on the moon, it will not sound like a quiet monastery. It will sound like a cramped industrial plant surrounded by a vacuum that's constantly trying to kill you. So, just like Earth offices, but with more dust and fewer HR posters. If humans can fake sound locally with metal and air, could the moon itself be used as an actual instrument one day? The way seismic waves travel through the moon suggests its interior is dry, fractured, and surprisingly good at letting vibrations bounce around for a long time. That's why some moonquakes and impacts cause the moon to ring much longer than equivalent events on Earth, where water and a more complex interior help to dampen the energy. In audio form, this gives a strange, drawn-out sustain, like someone hit a giant stone bell and then walked away while it kept humming in the dark. Future missions could, in principle, deliberately ping the moon with controlled impacts or vibrations and use an array of sensors to map its interior in exquisite detail, turning the entire body into a kind of planetary-scale resonant instrument. It is not hard to imagine a far-future civilization composing literal lunar symphonies from its natural vibrations, because if there is one thing humans are good at, it is turning raw scientific data into either art or unnecessary ringtones. So if the moon can be a bell, what happens when someone finally plugs it into a permanent 24/7 recording studio? Modern seismology and data analysis have already tripled the number of known moonquakes by digging back into old Apollo data with new algorithms, revealing tens of thousands of previously missed events. As new missions plan to put more sensitive instruments on the surface, the moon's subtle creaks, cracks, and impacts will be captured in unprecedented detail, letting scientists build a full sonic portrait of its activity, well beyond the grainy tapes from the 1970s. Combine that with modern sonification techniques, and the next generation of moon sounds will not just be spooky flavor for documentaries, but scientifically precise, high-resolution audio windows into the moon's interior and environment. One day, listening to the moon might be as standard a diagnostic tool as taking a spectrum, and also a very niche playlist category for people who think whale songs are just too mainstream. Thanks for watching. I just spent the last few minutes making the moon sound like a moody musician with seismic issues. If you want more strange but true cosmic weirdness, drop a comment with what you'd love me to listen to next, and hit like so the algorithm knows you enjoy mildly cursed space facts, and of course, subscribe to CosmoBinge so you don't miss the next time the universe makes a noise it absolutely should not be making.